Hi, welcome back to our final talk in this room for today. And we have a talk from Roger Ruttimann.
Correct.
Thanks. And he will tell us something about we should monitoring OpenStack environments.
How hard it is.
Yeah.
Okay. Thanks everybody coming for the last talk of the day. I know that I'm standing between now and the party that starts in an hour and a half. But I want to talk about OpenStack. I'm really passionate about OpenStack because we use it over the last couple of years and we are involved in the open source product as well. And we learned a lot. So I want to share what I learned over the years. So I'm the VP of Engineering at Groundwork Open Source, a company based in San Francisco that specializes on integrating of open source tools into a comprehensive solution. And as I said, today's talk will cover how to topic of monitoring virtual environments with specific for OpenStack. Here's the agenda that I will cover. So it's virtualization has an impact of IT administrators and DevOps, and in general how you manage your monitoring. How does OpenStack fit into the virtualization of today? The monitoring definitely has changed the landscape of IT managers. It's all different than it was 10 years ago, and I will give an overview what has changed over the years. New monitoring concepts are necessary to really answer the challenges. And of course, there are many tools out there to really cover everything. And the conclusion, it's more what we have learned over the last couple of years. So, but let's start with the facts. So OpenStack, it's real. Even some people say, oh, it's a little thing on the side and people are using it. It's complicated. Nobody will using it. But it's not true. OpenStack, it's real. It's widely used. It's not just an idea that somewhere happens. It's a challenge for IT. IT has to retool it because it changes the virtualization. There are serious deployments out there, and not just in Silicon Valley. Ask the telecoms in Europe, because there are many customers that are using OpenStack to provision their environment for telecom switching and routing. So a lot of things are going on. In addition, the open source project, it's very popular. The open source conference, it's twice a year and has like up to 10,000 people. The last conference was in Tokyo like 3 weeks ago. And in summer it was in Vancouver, the OpenStack Summit. So it's a big conference. A lot of corporate sponsors are there. So a lot of people are jumping on the bandwagon to adapt OpenStack in their environment. But the challenge is, again, a lot of tools can be used to manage and monitoring OpenStack. It's not just one tool. Just be clear, there's no one tool that can monitor OpenStack. And OpenStack itself, they don't have a tool to monitor the stack. So you need all these other tools. And here it's a combination of tools that we used in the field to monitor and manage OpenStack environments. And I will go into the details for all these tools. So let's start with reviewing what has changed over the last couple of years. We started like, this was the good old way to provisioning machine. You bought a server, you put it in a rack, you installed an application, you decided how to monitor it, you defined the monitoring, the thresholds, and then you were done, and then you repeated that process. And that's, you send up in a whole environment, and it was static. If a server disappeared, you know it crashed. You provisioned a new server, installed the application, etc. That was the way how monitoring was provisioned. And of course, then you had a dashboard, and then if an alert comes out, you get an email that says server so-and-so, it's not working, or a service check failed, and so on. It worked for a long way. This was the way of monitoring, and early open source tools that came out worked with these concepts of SNMP checks, SSH check, port checks, etc., to get the monitoring information back into the system. Then the first wave of virtualization came in, but all what was virtualized were the servers. The servers, the physical servers became VMs, but nothing else changed because you could provision the same way. instead of a server, you got a VM, you install the application on top of the application, you define the monitoring, and you could use it the same way. I think that's one of the reasons, because it was the same way as before, that VMware became very popular, because you had nothing to change. It's just like now you get a VM instead of a physical server, and you're ready to go. The only thing that came in is we got an API, REST API for the virtualization layer, so that the virtualization environment could give you more information about insights about the VMs and how the VMs are connected and some of the dependencies. So an API came in. So that was really the first API that came in, which was a SOAP API, not the REST API, that came in to give you information about the virtualization platform. But as we know, it didn't stop there. Software-defined everything was the next. Compute hypervisors, that was VMware, it's famous for. Storage and network virtualization came in, and suddenly we had much more tools, right? OpenStack came, RefM, NetApp had an API, Open Daylight, and so on. So the virtualization software came in for managing this the IT infrastructure. So the traditional IT infrastructure suddenly starts to change slowly, because you can do it virtual, faster, and all through APIs. And of course, then the public clouds are there too. So you have Amazon, Rackspace, Azure, all that. It's now, everything is virtualized. You get a virtual network, you get a virtual compute node, and as well storage. You don't manage it the same way as you did before. And that's what happens now. Everything gets virtualized, and suddenly the checks that you had before don't work anymore, right? So SNMP doesn't work in the virtualized storage because it's all managed inside. So to get the information, you have to go to the REST API to get the information out of the system. Same thing for the network, and the virtualization, the compute as well. So it really changed from what it was there before, that suddenly it's all dynamic, it's all through APIs, and the traditional methods don't work. And suddenly you have some blind spots. You can still do it at that level, the switches, because that didn't change, you still need that, but everything else was virtualized. So what we end up with, the landscape that changes, that's suddenly everything is connected. But most important, here in the middle, we have a shared I/O fog. That means even if you store a file, it goes through a network to the file server. Or if you go to a network, probably it goes to multiple layers of devices before it hits the other machine. So it's no longer a one-to-one that you easily can follow by looking at the switches and SNMP and so on. So it got much more complex. So that's a really big change that happened in the last couple of years. But then we think we have seen it all. We say, okay, now we can concentrate on managing what we have now. That's the new reality. We've virtualized everything. But then the DevOps weren't happy with that approach. What they came in and says, we need containers. And then Docker, it's a very popular container, so they replaced applications as well. So applications are now getting more and more deployed into Linux containers or Docker or Rocket. But what it is really is, it's application isolation. Suddenly, they're really sealed off. You cannot just get easily from the operating system. From here, the operating system, you can no longer go to the application. It's impossible, because that's part of the Linux container, that it's really isolating the applications from traditional monitoring. So if you want to look at the process table, if you want to look at other resources on the server for the applications running, you don't see it anymore, because the container now stays in the middle there. So again, that changed. And of course, since containers are now small applications, there are one process that runs something, then suddenly your application that was before one big server, it's like now 5 containers, 10 containers. Or you have 3 web servers in containers, and your application is another container. So you can have all these combinations, but it really makes that you can then really deploy applications rapidly and scale applications. You say, I need an additional web server because there's more and more load coming. You just provision it, and it shows up as a container. It's one container and not an entire application. So that really changed. But the problem is that the visibility into the containers, how to monitor containers, you don't see it anymore. It's all hidden from the operating system. So again, the checks that you do on the operating systems no longer apply to containers. So in fact, you are completely blind into the system. If it's completely virtualized, traditional monitoring with plugins doesn't work anymore. So it's a reality. But the thing is, Docker, for example, they are very concentrated on how to deploy, fast deploy our adoption. Nobody thinks about monitoring. They don't even have a monitoring API. Docker has only a provisioning API. It has nothing about monitoring how well the containers are doing, how much resources they are using, nothing. It just says they are deployed or not deployed and since how long. That's what you get out of the Docker host, but nothing about monitoring. If you want to know the process, the memory, and so on, there's nothing that comes out of the Docker. So that makes it even more, you're more blind in the whole system. So, and it really breaks down now, and that's what I'm saying, it's disruptive, and you need new tools to manage the new reality about virtualization. And of course, in reality, not everything is completely virtualized, and I will get to that, but in a highly virtualized environment that you start new, it looks more like that than what we had before with switches and routers and servers and applications and so on. So just to summarize, so what happened in the last 5 years? Virtualize everything, that's the big theme, right? It started with compute, followed by network, and now by storage. Different virtualization stack started to appear. So we have like VMware, we have OpenStack, we have Amazon, and we have KVM, which is down here. So that's the new thing for private and public cloud. So it's a reality, the stacks are there, and they get heavily used. But the nice thing is, every of these stacks, they have an API. Mostly there are REST APIs, and you also have REST APIs or SOAP APIs to manage it. So to configure it, to get information out, which is for monitoring, and so for the whole management, they have an API. So that's the fundamental change. It's like now everything is an API. Every new application has an API. And the REST API is a standard now. REST API is really lightweight. It's fast. It works well. JSON, it's JSON or XML, but almost everybody is using JSON because it's easier. So it's so easy to use that you almost forgot that SOAP or Corba, who remembers Corba, existed for doing the same thing. And the proprietary APIs, they go away because they are complicated, nobody understands. There are no open source tools and libraries to talk to these APIs, while for REST, in every language, programming language and scripting language, you have a binding for REST API that you can really get against API. So that's the new reality. It's API driven, and it's REST. And then, of course, what you then have, thick clients, it's as well a thing of the past. Now it's everything in the browser. Obviously, you have tablets, you have laptops, you have desktops, and you have phones. So having a browser-based UI, it's almost mandatory if you want to have adoption. So thick clients are gone as well. Everything is JavaScript, because all the tools we are seeing and all the presentations we have seen here so far, it's all about JavaScript UIs. There's no longer thick clients and all this server-side rendering and so on. It's all in the browser. So again, that shifted us very away from what happened a couple of years ago to now. So what's the lesson of that? It's all JavaScript, REST and JSON. If you talk that, then you can talk to all this system and get this information. And again, you can see how you can start again monitoring these systems because you can talk to these systems. So that's a tool set has to be adapted to have something that talks REST and brings information back that you can then again look into your system what happens for monitoring. So that's the general trend. So the next thing is like, so how does OpenStack fit in? So OpenStack project started like 9 years ago. It was about virtualization, an answer. It started as an answer to VMware because it became too commercial for some of the people, for some of the purists. And they came up with a new architecture how to do virtualization. It's open, it's a service-oriented architecture, so they really split compute, network, and storage, and authentication and visualization in services. Everything is pluggable, so your hypervisors or network adapter or storage adapter, it's pluggable. So in OpenStack, you can run KVM, which is a default, but you can run as well VMware ESX, or you can Hyper-V, and so on. So they want to be open and not be a lock-in for any vendors. So it supports a wide range of technologies, and it's especially important for network, because there are a lot of controllers, network controllers, SDN network controllers adapted that work well in OpenStack. So that's a big market in OpenStack to have network devices. And the other thing is about elastic compute units. So in VMware, you could define your image, your size, and you just created it. And it didn't have to fit into a memory range or a disk range. You could create whatever you wanted, and the alignment was then done by VMware. While the elastic compute, it's a multiplier of a small image. So you have small, mid-size, large images, because it fits into how it gets computed and optimized. So it's really for optimization of compute resources. That's what it means, elastic compute units. And that's really important as well if you have container deployments, because you have a lot of small things that you can really well align in memory usage and storage usage across the whole system. And this started early to have APIs for all services. So this is OpenStack, the project, the mission, and everything. Sounds really good, because that's what everybody asks for. It's like, we need an open system that's pluggable, that has APIs, it's easy to manage, you can do whatever you need, it's a competitor to VMware, it's cheap, it's a great system. But what's the reality, right? So why is OpenStack not ruling the world today? Maybe in a couple of years, but not today. There are some issues with OpenStack in general. Let's talk about that. That's the OpenStack architecture. So people say it has been simplified. You can argue if it's simpler than before, but these are all the services. So compute services has always multiple components. So the service-oriented architecture you see here for storage, for compute, and authentication and dashboard. So it's a whole assembly of services which are really complex, and it's a lot going on there. So here, of course, this box, it's one service, but you have a lot of microservices in there that you have to make sure they run, that this whole box runs. So the complexity of the system didn't get simpler. Even the mission was like to make it simpler. They wanted to abstract it to the user when they install OpenStack. It's all simple and it runs easily and you don't have any problems. But what you can see with this complexity, it's not easy to maintain and manage a system of that. But as I mentioned before, every component has an API. It's great, but instead of having one API for OpenStack, we end up with 7 APIs for OpenStack. So we didn't really win at that point. So what's really necessary, and that's my company are involved to create a unified API for OpenStack and give it back to the open source community, have it in there, because each of these API have some metric counters about each of this system. But the majority of the APIs, it's about provisioning, it's about setting up, it's about configuring users and so on. And a small fraction, it's about monitoring. Again, when you talk to people in OpenStack, they say we have to address first a big problem about configuring and managing the whole stack, and then we do monitoring. They said that 3 years ago, they said that 2 years ago, they said it this year. It hasn't really changed. So the thing is the need to having a unified monitoring and API. Just for monitoring, it's necessary for Sysadmins and DevOps, because you need to monitoring a system like that. There's no question about that. So we started to create this the API and put it on GitHub to have a start in the whole community process. OpenStack is a community-driven process. You have to propose what you have. You have to go in front of a committee, present it, and then it gets in an incubator, and then it gets all the way up until it gets delivered as the final product. So we are still in the free incubator thing because we try to get a lot of the project owners to help us for the monitoring as well. But of course, they are preoccupied with other things, so it's really hard to get traction, but we're working on that. But that's the open source way as well to get an API into the product. And what you get, like counters, you see here for the hypervisor, you get a few counters about how much disk it's used, how much memory, and then how many VMs are running. So it's really minimal. And the same thing on another service, the Ciliometer, which is a metering service, but it has some monitoring information in there as well. So there's only a few information there. But if you go for the virtual machine, there's a lot of information already in there. So that's a good thing. So the team that worked on the VMs, they really paid attention to the monitoring, because what you can see as well, they have regex expression to define about network monitoring, disk monitoring, CPU and memory, and so on, of the VMs, which is really important to have. Still, improvements necessary here, but at least they understand what's necessary, what's necessary for a sysadmin, what's necessary to really manage virtual resources on top of your system. But now I step back again. So, okay, we have this, even if we achieve the perfect API for the OpenStack, we get all the information out of OpenStack. We get it out of the hypervisor, the storage, the network, how they are aligned and everything. It's not the whole picture, right? Because in reality, you still have a legacy network. You have to have a network. There's no question that you have a router somewhere here. You have an ISP. You have some connections. You have servers out there. You have file servers that sit somewhere on your system that you use for legacy applications. Nobody just runs OpenStack. Or maybe a few companies just run OpenStack, but the majority, they have something like that and much more. And OpenStack, it's more a side project. They just want to prove that it works. But they have the whole legacy. So maybe these gray boxes, they are much more in reality. So you still need the monitoring tool for that. You still need an application and infrastructure monitoring for the servers and storage and network that you have with the traditional plugins, SNMP, and so on. But what's more important, even OpenStack, all the services here, you want a monitoring on the hypervisors. For example, is the MySQL server running for the identity manager? Is all the processes running for the hypervisor management? So you still need some inside information of a system to really make sure that the low-level infrastructure it's running, which are these checks, and then you have the API to see if the management functionality and the provisioning, if that's working. So you need both. So just having an API, it's not all what you need. You need the traditional plugin monitoring as well. But of course, in reality, what we said with fast deployments, new resources, and so on, you need the whole provisioning infrastructure, which runs on a separate servers or on separate multiple servers to create the provisioning, creating the virtual machines and all that. You need that infrastructure as well. And of course, you need to monitor, again, outside of OpenStack, this whole provisioning stack. And to have a complete coverage about monitoring and management of your thing, you need, of course, you have containers, because now everybody tries Docker and Linux containers, so you have to monitor that as well, which would be another tool, which is not part of OpenStack. And of course, for everything, you want to have performance data. So even in the virtualized world, you end up with 5 different tools. So we didn't win much over the last 10 years because it just got more complicated. It's still the old story, but it got more complicated. So what we need, it's a unified view, right? We need to combine all the data from all the systems to show them in one UI. That's really the goal, what we should work to. But to get a unified view with all the data, we need a standardized data collection. We need to get all the data from the different tools, not just from one tool, not just from OpenStack, not just from the application infrastructure monitoring tool, not just from this side. We need all the data then we can get and standardize it, and then we can create the dashboards that we need to do. Again, so what's a unified view? If you have silo tools, It's really hard to correlate. It's really hard to figuring out, is it a network problem or a storage problem or a compute problem or a configuration problem, because it doesn't line up, right? Every tool tells you it's perfect. So that's the third one. It's not my problem, it's your problem, right? How many times have you heard it's a network problem? Has nothing to do with the compute. How many times have you heard, no, the storage is fine, it must be something else. So if you have multiple tools and they are not unified, it's really hard to find the root cause. Especially now we have these multiple layers. We have network and storage and virtualization and API. It's like, where's the problem? Because it's aligned. And then you tend to have over-monitoring, because you say, we really have to cover everything. You provision more checks, but you don't really monitor. You monitor around the real problem, because you cannot get to the virtualized router. You try to monitor everything around it, but you don't really pinpoint the problem that you have in the middle that you need to do with an API monitoring. So what it is, what we call the stack monitoring. What it means you get all the counters in, all the metrics in, you put it together and you show it under one device. Everything that's involved, if it's a network, the storage, the compute, the container, the application, that you see it in one. And if you have all bundled together, then you can decide where is the problem, because you see the mismatch in the checks. If the VM says, I have 4 gigs of memory provisioned, but then the operating system says, I have 8 gigs of memory provisioned, then you know there's a mismatch there. But if you have 2 separate tools, you will never find that, because every operating system says it's fine, right? But they don't say, but the interaction doesn't work. And it can work well if the hypervisor is not over-provisioned, but as soon as you have more and more resources, the hypervisor gets busy, starts swapping, and says, I cannot provide you all the memory that you ask for. And then you get a mismatch, and then you get some alarms on some of the checks. But when you see it in a group, then you see where the problem is. So it's a really important thing. And the second important thing, it's aliasing of names. Because as you can see, for each tool has their own naming. And it's first of the tool how you name things. The operating system, you have the DNS name, which is all lowercase and has no special characters. You go in a container, which has just a long hex number. So how do you alias to? You have to alias together. Says this container and this VM, it's the same thing, because they're running together. So you have to do that the checks and line up. And the same is for storage. If you have like a filer that has a volume somewhere, you name it A, and then in your virtualization environment, you create a storage device and you name it B. You would never know that they are the same devices. So you have to alias together, says this, the storage device and the filer volume are the same, and then you get the values together. So that's really important, that the aliasing, that you can alias it, because even people can never agree on names. That's the other thing. How you name devices, how you name services, and how you name, if you use the IP address or the name, the fully qualified name or the short name, everybody's different. And then containers, they don't even use any of that. And controllers and routers, they do it differently. The software-defined network, they use another scheme for names. So it's really hard. Automatically discovery and alignment of names doesn't exist. What you have to do, you need an aliasing tool or a way to alias names together when you know they are alike. And again, you need the information from all the tools. So you need collect the information from whatever is available, which is the best tool for the job. So that's really important, because there's not one tool that can do everything. It's like you really select a tool that's best for it, and then bring the information into a master system, and from there you can then use it for troubleshooting. So here's just an example how in reality that works. So the hypervisor here, of course, it sits on the network and storage. It has the hardware, identity server, operating system, and then the OpenStack API for managing. That's the whole hypervisor stack. What I have here with the host name, of course, you have IPMI. You have a different IP address with a different name than the actual server, which I have here, right? The server 1, but here you named it drag server 1 because it's a different IP address. It has a different name. But of course, you do the the monitoring, it's the same hypervisor, right? You do hardware monitoring and you do the operating system monitoring. It's the same device. And of course, the OpenStack identity server, it's a MySQL database running there. And then you have the server name and port that comes back. So it's not that obvious that this altogether should be one server, as I have here, that you have the hypervisor. So you alias it together to one name. So what you want to have, it's a whole list that shows you the whole stack. What I have here, IPMI checks, and then here I have from the virtual environment the checks that show it. And then here I see, oh, the power supply, it's failing. So of course, at that level, you don't get an alarm at that point because this is failing, but you know that that can cause a problem in the future. And in the future, if that happens, if the IPMI then gives you a check, a failure, and then your hypervisor goes down because the whole power goes down, it takes you a while until you find that. But as soon as you start building the whole stack and have all the checks in, you can then as well predict failures or see there are mismatches or even other misconfiguration. You find it there and you can address it before it's too late. So it's as well, you don't want to get called in the middle of the night of something that you could have seen before because it's coming. Same thing goes on the VM. Of course, you have the operating system. Here I have a Docker host, and then I have a container on top of it. So you see, again, the names are all different, but of course, you want to combine it together and have a view that shows you Docker checks and for the virtualization checks to see, especially, you want to see the Docker container memory and process configuration, does it match with what I have from VMware? It's really important because if there's a mismatch there, it might run well now, but then suddenly the machine gets really busy and the balloon memory and everything doesn't align that well anymore and it starts failing. It's because of a configuration mismatch. And again, if you don't have it aligned and see it in one view, it's almost impossible to troubleshoot the issue. So that's the one thing. That's why you want to have collecting data, aliasing data. This is the case why you need aliasing data, that you have one name, that you see everything under the one structure. The next thing, we have that heard before in the talk, automation. It's really, really important. You can no longer do it by hand. Manual configuration of monitoring, it's impossible. Especially with the virtualization, with containers, they get started, stopped, started, stopped. You have no time to configure anything by hand. It has to be automated. It has to be an automation API. So since it's all automated and changes all the time, the monitoring has to be the same way. What's really necessary is that the monitoring system where you collect the configuration, where you have plugins that do checks, and then you collect data, that gets reconfigured automatically, dynamically. It's like a flight recorder. When a container starts, when a VM starts, you want to start collecting graphs, metrics, all the data that you can in your dashboard to show up automatically in the dashboard without doing anything. That's your goal. And the way you can do that, it's like you synchronize the configuration, you talk to the API of your virtualization manager. That's what it is here. And it says, hey, there's a new VM. You go in and configure the plugin. You configure the plugin that does a check for this new VM. You say, I want to have a check, a hardware check for this new plugin. And then it starts configuring it automatically and starts collecting data. And then, of course, since we have the connector, we ask the API as well and says, give me all the information about this new VM. Give me all the details, what you have for this new VM. I collect it, I integrate it, and it shows up in the dashboard. It says, here's a new VM, here you have the performance data, and you are happy. Then you see it's there. So it's really important that that it's all automated because there's no way that you can do it manually because you would not see it. And as well, then, if it gets unprovisioned, it goes away, you remove it from your dashboard, it's all gone. You don't care because it will not cause any problems. But as soon as you add more and more resources and you see that in your dashboard, gets more and more data in, then you see, hey, I overload my hypervisor or my storage is misconfigured. And then you can go in and change the configuration of this system. And then the configuration picks it up and adjusts everything, and then it gets balanced. So that's why I'm saying the dashboard is really important for the DevOps that manage the virtual environments, because they have to watch what's going there, doing configuration changes, provisioning changes, but the monitoring system has to pick it up, because nobody manually will change the configuration system. If you say, I move this VM from one hypervisor to the other, it gets picked up here, this gets reconfigured, and the data collection works. You don't get an alarm because a VM disappeared from one hypervisor to another. You should never get an alarm. It's still there. It has been reprovisioned. So it should be all automatic. So that's the reality today, that you have to have the negative feedback loop, that if you do provisioning changes, the monitoring picks it up without any manual intervention. So that's what we call the automation, the continuous configuration discovery. You have to ask through the API what's going on in the system and adjust it. So now, what kind of monitoring tools are available for OpenStack monitoring? So what I have here, it's the hardware that you say, I want to install OpenStack. Let's talk, this is about the deployment process, right, to set it up. And then this is open source tool Fuel. It's very popular for OpenStack provisioning and setup. It's there are many out there, but this one, it's one of the better ones because it has a nice UI, browser-based UI, that you can configure your entire OpenStack through the UI before you even start deploying it. And what it does, it verifies as well that your network, it's okay, because that's the biggest problem deploying OpenStack. It's like your network and your switches that you deploy the whole thing has to be set up correctly. You need public and private addresses, needs to be set up correctly. You have to tag the VLANs correctly. Fuel checks all that, and if it says it's okay, you can press a button and it deploys the hypervisors, the storage, and all that, so what you have configured. It just deploys in one button, which is a really great tool. And then half an hour later, if you have done it all right, you have an OpenStack up and running. And it's working, it's guaranteed working. And I think that's part of the success of Fuel. And the thing is, then you decide, hey, I have another server, you bring it in, you go to Fuel and says, here's another compute node, another hypervisor. Fuel does the verification, adds it to the network, and you just deploy it. So it's really easy. It's really a great tool to do that. But that means then you have the OpenStack running there. So you have the environment, you have the virtual environment up and running. But then there's another tool, the open source tool, Murano application repository. What it is, it's a catalog of applications. There are VMs that they are in the catalog, and then you can decide where they should be deployed. And then you can decide, okay, I need all the monitoring, and I bring in my Icinga 2, I bring in my OpenTSDB, and then I have some Docker environments, which has already BoxSpy, which is another open source container monitoring tool, which is then provisioned there. And here, this could be inside the OpenStack as well, but I just draw it here to say it's our unification layer that you need, the unified monitoring view, the data management, and all the collectors. So you can deploy that through Murano because they are in an application catalog. And again, if you go in and deploy, if you want to add some other instances and all that stuff, you can do it to the catalog. So Murano and Fuel are two OpenStack projects. They are part of OpenStack, but they really help for deployment and provisioning resources in OpenStack. So this is great, but the problem is it's all sitting there and doing nothing, right? Because it's not configured. So the other next big innovation, it's Fuel plugins. Because when you provision Fuel, when it installs it, it creates as well SSH keys. It knows where the APIs are, where the password, the credential, everything gets generated in Fuel. And the plugins can then use that to configure software. So you can then configure Icinga with SSH key, SSH check for the operating system and the hypervisor and storage. You can configure it directly with the SSH key. It's all there. And then as well where the data should be sent to for collection. You can then provision as well this tool and says where the OpenTSDB is, which VM resource it is, etc. So you, with the plugin, you have all the information that you can then deploy, configure your OpenStack, the application deployment. Once you have done that, it's running, it's configured, all the APIs are configured, and it starts monitoring and sending back information and collecting information. So it's really the plugin, there's a large repository that application developers start putting in instructions how to configure tools. So that's the one way then to get all the connections. What I put here as well, so that's then the deployment that you want to have, then it's up and running in your OpenStack and you monitor your OpenStack. And of course, if you add new VMs in here, because the monitoring tool, it's going for the controller, which really manages all the resources. Since it's now connected here, it's automated. If you have a new VM, it gets here, it gets the feedback here, and then it starts collecting information because it gets reprovisioned. But as well, from here, it can then be pushed down to Icinga and says, add this new host for some checking. You can do that as well. So that's a two-way between from here back to Icinga, for example. So here we have the whole monitoring. But another thing, it's like the performance data. You want to bring in the performance data. Again, from all the resources that you have, you want through the API, you want to send it to OpenTSDB, all the metrics that you have. Again, here's an API, and each of this one could then send it to OpenTSDB, the metrics. You just send them in as a raw metrics. That's an important thing, and it has a centralized API. Of course, OpenTSDB, it's an expandable storage. So if you need more, you can add more, you can cluster it, and so on. It's a really great performance data database. And then on the top, what you want to have, the UI is Grafana, which comes, OpenTSDB has Grafana as the default now, which is a great improvement they have done. And what it helps to really to look at historic performance data, which is the raw data you can search. But what's more important, and we saw that this morning in the call, that you can do searches for metrics. You can say, give me all the CPU memory across all the hypervisors with wildcards. And then you get a graph that you see all lines, but you see then outliers. Because one hypervisor, it doesn't behave well. It's over-provisioned or under-provisioned. Or you see spikes there, and it says, oh yeah, we had the spike, and then we reprovisioned it, and it came back, and that helped. So performance data, it's really like the view of the system that you can then react when you see it gets overloaded or underloaded as well, because you have some systems that are really highly loaded and some that have almost no data. Then you start moving VMs on the other hypervisor, and you should see that immediately in the performance database. So that's really the combination of the performance data and all the other metrics for availability and event management. You need to collect all this data from different sources. Again, there's not one tool that tells you everything. You need multiple tools to get it reported back. That brings me to the reference architecture for monitoring. What's really, remember the first slide where it was like you had one tool that was good for monitoring your entire network. Now we change, you will need multiple tools, and they need to have APIs. Because what it is, the collector needs to talk to the different APIs, bring the data in. You need a hub, a collector hub, to get all this information in, that to get the data from the different systems. And afterwards, you do the integration, and that's the hard part. And that's like quite some companies are now moving into this part to do the data integration, where through an API, you bring the data in, you normalize the data, and especially you do the aliasing, because the next step you want to visualize, and again, you want to have the data that's related on the other side, but you don't care who collected the data. That's an important thing. You just want to see the data here. That's important. If you have some missing metrics or some missing counters, You go on the other tool and add it there. You add it to the tool that's best to do this check. It's a hardware check. You would use Icinga. You know you have a counter missing in the VMware. You go to OpenStack, etc. So that's how you adjust it. But then it flows through the system, gets integrated here, and the performance data, and then the dashboard that you can then really use this view to do the provisioning and the adjustment of your virtual environment. So everything is API. That has changed. There's not one that can do everything, so you need multiple tools. So that's an important thing. So what's the benefit of these approaches? So automation, automation, automation. I think that's the only thing I can say. So because configuration are dynamic, you have to automate it. You have to have API calls. You have some glue scripts or logic to bring it in. But it helps as well to streamline operations, because you have to have a standard how you get the data in, what you do with it. So again, it's not a manual process. There's no intervention from people to can misconfigure something. You have to use that. Hardware, again, OpenStack, here specific OpenStack, there's no vendor lock-in. That's one of their mission that OpenStack has. It runs on everything, but you get the benefit of elastic compute, flexible architecture, pluggable architecture, so there's no vendor lock-in. And the API, 3D transparency is through the API, because everything talks API, and you get a lot of information out of the API for configuration and at runtime. We talked about capacity and resource planning. So since you have a view from the bottom, from the network to the top to the application, you can now see where are the bottlenecks, because you see the whole stack in front of you, saying it's like, I know it's a problem in the network or in the storage or the compute, the CPU and so what I align. That's where the problem lies, and then you can adjust it. And then allocate the resources where necessary. So, and as well, you know that even you talk about storage latency, it's slow. Maybe it's a network problem, because the throughput going to the storage, you would have it if you run it isolated, but since you have the application goes to the same network as the storage goes to the same network, then you say, we have a latency problem there. But then you say, we just distribute across 2 virtual networks. And then suddenly you see, okay, the application uses a different network than the storage. And suddenly probably your bottleneck goes away. But before you see that, who has problem with the network latency, you cannot make these kind of decisions. So instead of buying more storage because the storage is slow, you just create a new virtual network, and then it's all good, because that's the problem and not the storage and not the filer. So that's one of the common problems, that it's like, because you don't know, you try everything, and then if it works, you say, we figured out the problem, what it is, but it wasn't, and then it comes back. And before you have really detail about the whole stack, it's really hard to really find the root cause of slowdown or latency problems, or of general slowness of applications. And I think what the other thing, big change, is that the sysadmin and the DevOps functions start to merge. Before, it was really the system administrator was there for the IT infrastructure, for the servers and operating systems, and the DevOps were just applications. But now it goes all together, because virtualization and containerization becomes a part of IT. So sysadmins and DevOps, almost the same function. You manage it to management tools for the virtualization and so on. So there's so much overlap that I think that the function will merge. So you will have more specialized DevOps, sysadmin, or whatever. Maybe they come up with a new name at one day. So I think that are really then the benefits for virtualization platforms for OpenStack. But in general, if you do the monitoring right with the right tool, that's all the benefits you get. So working with virtualization and these different virtualization environments, not just OpenStack, but VMware and Amazon and Azure and so on. So what are some lessons learned? One thing is definitely that virtualization is a reality, right? It will not change. Nobody will move back and say, oh, we go back to the server model. A shocking thing, it's like before virtualization, the hardware utilization was about 15%. When the VMware virtualization came in, it went up to 35%. You think that's not a lot, but it was 20% better utilization. Since elastic compute comes in, it's closer to 60%. So the utilization gets better, more benefits are there. So it's a reality, it will not go away. But what doesn't go away, it's as well the legacy hardware and software will be around. Nobody throws out all their system and brings in just a virtualization platform. So you need the old tools as well. You just need to integrate the tools, that you have one tool to manage everything. So API is important. More and more tools and software come out with APIs that you can use. So you have to retool how you manage and monitor. And of course, it's through APIs more and more. Aliasing, it's really hard because it causes a lot of problems when you start renaming devices. But it's still simpler than try to agree all the departments in a company about naming and process and workflow. So you rather spend it in software development than trying to change a process in a company. But still, it's absolutely necessary to get aliasing. And the best thing is like you have both. You have a standard, but there are some exceptions. You manage it with aliasing. Use the best tool for the task. As I said, it's like you really to select what's the best tool. Has an API, goes under the cover. It's specialized for containers. It's specialized for software-defined network and so on. That's what you have to take and integrate. Don't over-monitor to cover the gap. That's the other thing. It's like, I can do it with my tool. I have done it for the last 10 years. Don't do that because you don't monitor. You look at not at the right spot because you just try to have a lot of coverage, a lot of counters, a lot of performance data, but you never analyze the real problem because you just try to cover the shortcomings. So here's the last slide, the conclusion slide. So really important is that open source tools are the driving force of innovation. All the things that we saw in virtualization, a lot of things came through open source tools, to open source initiatives. OpenStack, it's a big one. A lot of the software-defined network and software-defined storage came through OpenStack projects, and it's now really the driving force. DevOps just select the best tool to do the job. So it's more the pragmatism of DevOps that's now the mode of operation in data centers and in IT departments. Again, a single tool to rule them all doesn't exist. So monitoring, you need multiple monitoring tools and combine the results and then and visualize it. Integration, it's a complex task. Again, teams will never agree on naming and process and workflow and so on. So this is part, makes integration harder, but with APIs and tool sets that are around it, it's doable. And again, automation, there's nothing else to say there. Virtualize everything will continue. So we see more movements as well. If you look at the virtualization of containers and VMs inside OpenStack, it seems to merge together. That in the future, you don't have a VM and a container, you have something like a virtual container or something like that. Because to just get a smaller footprint of your compute element, it's really important. Automation and continuous discovery, it's necessary, no question, because you cannot do it by hand. Again, OpenStack, it's the open source virtualization platform. It's really popular, it's growing, it's great, but monitoring still needs major improvements, major input, and contributions from all IT administrators and people that go to open source conferences like that. They need more contributions to that regard and to make it more important, that it becomes to a more important task that monitoring needs to be added to OpenStack. Monitoring needs to be added to the API so it can really be used as the next step. So what I'm saying, it's OpenStack, it's the open source platform, and it's a project that it's growing, gets more popular. So we just need more contribution to it. Thank you.
Thanks to Roger. So we have a few minutes to some questions.
No question.
Who has a question?
I don't have T-shirts.
Maybe that's the reason.
What's the role of Groundworks open source? Do you have all this stuff integrated in your product, or is it just experiment what you told us about?
So what we have written a connector, the hub, that talks to all these APIs to integrate it.
This
so
facade thing,
yeah.
The Greek temple.
The Greek temple is our contribution to the open source, to do in the OpenStack, to be the involvement in the OpenStack organization. But as well in our product, as a commercial offering, we have the Cloud Hub in there, which is the API collector in there that brings in that talks to all the APIs that you have and bring it in and does the aliasing. So that's why I know about the aliasing, because we spent quite some time to get the aliasing right. Mm. So that's part that we try to do this, or we're doing this integration of this multiple metrics in a unified UI. That's really where we're going at, because we see that's a big demand on IT administrators.
Thanks.
Okay, thank you.